Hey everyone. We're just gonna wait a minute or two to let some more folks trickle in. Um, while we're getting started, feel free to throw an intro in the chat and let us know where you're calling in from. France, Jersey, more France. Yeah. I almost typed hi, I'm Kyle from California, but I realized your name is on there. No, really good global representation on the call. Just a MacBook Pro. I'm not sure. Thanks for the compliment, though, Charlie. Appreciate it. Alrighty. So we're a couple minutes in. I'm gonna go ahead and get started. So welcome to the latest edition of Datafold's hands-on lab. We're super excited to share what we've been working on. Today, we're going to focus on test-driven development with DBT and our open source data-diff tool. My name is Kyle McNair, and I'm a data engineer at Datafold. Datafold caught my eye because they're focused on data quality, which is an area that I've felt the pain at previous jobs as a data person. The solutions and problem space really resonate with me. We're focused on improving the lives of analytics and data engineers. Our workflow-based tooling helps flag data quality issues before they make it into production, so you can move faster and with greater confidence. By the end of this call, you'll know what's a data diff and why you need them in your life. And we will get you set up using data diff in a real DBT project. You'll run some diffs and see the tool in action. And just a note, we've designed this call to allow the audience to try out data diff real time, but no pressure. Feel free to simply watch, or you can try out the tool on your own time. On our to-do list, some housekeeping. I see Leo's already mentioned it in the chat, but we want to get everyone in the DBT Slack if possible. I'll give an overview of what we mean when we say data testing. We'll get our hands dirty with the demo, and everyone on the call can try out the tool. And finally, we'll cover what it takes to implement data diff in your DBT project. So again, if you're not there already, please join the tools-datafold channel in the DBT Slack. As we go along, we'll be posting links in Slack and in the event chat. Helping me out today are our friends Leo Folsom and Dan Lowen. Dan largely built the DataDiff DBT integration, and Leo also made some significant contributions to the tool and is really knowledgeable about all things DBT and the modern data stack. So between the two of them, they'll be able to clarify and correct me when I'm off track. They'll be keeping an eye out on the DBT Slack, the event chat, and can help out with any questions that might arise. So let's get into it. Thinking about data quality, how does it make you feel? Throw a response in the chat. Clueless. Yeah, loaded term for sure. Yeah, triggered. So for the average normal person, data quality is is boring. But for a data person, myself included, and someone it sounds like somebody in the audience, data quality can be deeply traumatic. I have a number of nightmare scenarios where I've been personally responsible for data breakages. Very briefly, a highlight of mine occurred while working for a healthcare company. I jumbled claims data, sent it off to Medicare, and accidentally inflated our projected revenue by tens of millions of dollars. I bring this up because I know there's people in the audience who have also had some highly consequential data errors. Yeah, and again, feel free to share if you feel comfortable. And if you haven't experienced a nightmare scenario like this, it's really only a matter of time. For those that have felt the pain, I'm here to tell you that it's not your fault. These data issues where there's a lack of quality in testing, are not people failing. I'm convinced it's a failure of process. It's a lack of tooling. 23-year-old me manually chopping up CSV was inevitably going to make some kind of catastrophic error. So there's got to be a different way, right? Enter data testing. At Datafold, we talk about data testing around use cases, two of which are development, which is the individual going single player mode, and deployment, which is where the process becomes more of a collaborative team mode. Seeing this visually, development testing happens way left, typically before you open a pull request. This is you developing locally on your machine, writing ad hoc SQL, and hanging out in the command line. Just doing DBT runs, DBT tests. This talk is focused on that development space, and this is where our open source data-diff tool fits in. Deployment testing happens a little further right. That's after you open a pull request and kick off your CI staging job. If you're familiar with Datafold, you might have heard the term data-diff associated with deployment or CI/CD. That's our cloud product and not the focus today. So flipping back to development testing. Again, all the way left, when you're working on changes solo. When developing, how do you check your work? Throw in the chat. We've listed a couple options here. We've got, can do nothing. Ad hoc SQL queries. We've got DBT tests. We could dump to spreadsheet. Lots of B's. DBT tests, B's and C's. All right, so I'm not seeing any A's. This is pretty self-explanatory. You just roll the dice. I'd say ad hoc queries, just things like counting records, looking for nulls, maybe some outer joins or set-based logic. We've got DBT tests. That's assertions about values, about uniqueness. And the classic dump to a spreadsheet, copy paste, do some VLOOKUPs, then you're rocking. So armed with our basic data testing tools, let's put it in action and talk through an example change. Let's talk through what's should be a simple update to a model and think about data testing. This is a real example of something that I ran into our DBT project. So we've got a dim orgs model, which is a core entity. It's built around organizations. That's built on top of my user signed in model. I decided I want to swap org created events for the sign-in events. I thought it made more sense to build an org model around org created event rather than a user signed-in event. I was imagining maybe an org never had a user sign-in and would be missing from the table altogether. So logically, this change seemed pretty reasonable and relatively safe, right? Maybe. Here's the change presented as code. It's only a couple lines of code, but yeah, apologies for sharing code here, but that's sort of the point. Code's really hard to read. If I put on my coder view hat on line 7, I can see we're swapping sources from sign in to org created. 4 and 5, I can see we're adding a couple columns, org name and employee range. That's okay. I'm not super worried about that. And then line 6, we're swapping this created at from the org created event with this minimum event timestamp from sign in for a proper org created at timestamp. So that's good. I feel better about that. It feels like an improvement. From here, do you confidently push to production? Let's check with U.S. Secretary of Defense Donald Rumsfeld. So he's got a development testing framework we can learn from. We've got our known knowns. We're swapping models. We're adding columns. We've got known unknowns. I know there's a couple downstream models that could have some records changed, and I expect some kind of impact to those models. I'm not sure exactly what. I know that org created it is changing, and I'm possibly adding a few orgs if it never logged in. And then you've got your unknown unknowns, which could be anything, and that's the most terrifying piece. These are all areas that we'll want to investigate. So turning back to our existing testing tools, let's think of some ad hoc queries to investigate this change. We can check for uniqueness, just a count distinct of the org ID. That looks good. We can check for null IDs. This is good here too. Let's check record counts between prod and dev. That's easy, right? So counts are different and it's off by 11. It's not in the direction I expected. It looks like we might have lost 11 records from our dim-orgs model. So we'll keep an eye on that. More ad hoc fishing around. We could use an accept to for prod versus dev, and we can see the missing 11 IDs. I could do a left outer join to see full detail on the missing 11 records. If our missing records from both sides, I could do a full outer join. So I'm starting to get an idea of what's going on, and I'm really glad we didn't just push straight to production. Yeah, didn't merge and go on vacation. Ad hoc queries were a good call here. DBT tests could help cut through some of those ad hoc queries. Simple not null and unique tests on our org ID lets us know we're good on that front. I have a relationship test on a downstream model to make sure references are valid. So sort of a foreign key constraint, and that passed. I can even just do like dbt build and run everything downstream. Everything ran downstream and the tests are passing. What about our trusty spreadsheet? We can dump IDs to a spreadsheet, do a VLOOKUP, and find our missing 11 records. The point running through how we might check a change like this is that these methodologies are scattered and manual. It's hard to be consistent with testing. It's way too easy to make a basic mistake like dropping records from a core model. Even if we eventually catch an error when testing during development, does this feel way harder than it should be? This required manual queries, some thoughtful DBT tests, maybe some Excel. Not only is this style of testing difficult, it's inherently inconsistent. You very likely won't check the same things as a teammate or even the same things as your past or future self. So we let humans take an ad hoc approach and hope for the best. And this is where data-diff fits in. A data-diff is similar to a code diff like this. For those of you used to working with version control like GitHub, you're very familiar with this concept. It's the differences between two objects, comparison of before on the left and after on the right. But in the case of data, it's a comparison of the data being created by the code. So the before left is the code that's currently powering production, whereas the after right is the code you're working on in development. These are the underlying tables created by the code. Notice the shape of the dev table has changed to include our additional columns. With data-diff, we stitch those tables together to get a cell-by-cell comparison, and it makes it much easier to spot the differences between two tables. We can see that values have been added, deleted, updated. This diff table shows some org IDs that are dropped and some changed values for the created at field. So let's combine that data-diff concept with DBT. Sticking with our same change to the dim-orgs model, we can use data-diff to accomplish much of the testing we covered earlier, but in a fraction of the time. To use data-diff with DBT, you simply tag data-diff --dbt on a normal run, or you can run it as a separate command. For context, Data-diff needs to piggyback on a DBT run. It'll read the artifacts to figure out what models were built and then compares your dev models to your prod models, if that makes sense. So seeing it in action, here we do a DBT run on dim.orgs, and then we run a data-diff. Data-diff picks up that dim.orgs is built and compares it to prod, and gives us this great output. Taking a closer look at the output, we can see what's being compared. Prod.dim.orgs versus dev.dim.orgs. Perfect. That's what we want. We're comparing prod versus dev. We can see that 2 columns are added, org name and employee range. So schema change summary. In the next section, we can see that 0 rows were added and 11 rows were removed. This is that big finding that took us a while to find earlier via ad hoc SQL. We'd have to know to look for it too. Data-diff found this right away. Moving down, we can see that 112 rows had some kind of update, values change. And the values updated section helps us drill into exactly what fields had values change. It looks like those 112 updated rows had some kind of change to the created at field, and all their fields were unchanged. So with data-diff -dbt tagged onto a normal DBT run, we've already gotten some nice info that under normal circumstances we'd potentially miss, or we would need to do some ad hoc SQL or spreadsheeting or DBT tests to find. This new check is easy and it can be consistently applied, and why not? What about downstream models? So dim.orgs has 3 downstream models, and I don't want to blow those up. You can use dbt's node selection syntax to diff multiple models, including everything downstream. So again, data-diff looks for artifacts from the last dbt run, and it'll just diff every model built. Whatever syntax you use to run models, data-diff will just look at the models built. So when we add our plus selector to your dbt run, data-diff will just do the rest and will diff all the models that are built. So this will run dim.orgs plus the 3 models downstream. And exciting development, 4 successful model runs were found by data-diff. And we'll get the output, the data-diff output for all 4 models. So right away I can see, again, schema changes, records added or dropped, fields with change values. Specifically, I can see we're removing and updating records from models that are called fact monthly financials, fact yearly financials, sales sync. Knowing nothing else, those sound important. I know people care about money. I'm glad we flagged the impact, and I can begin to understand the degree to which they're changing. All right, so I know everyone's pumped about data-diff now, and we're going to jump into our hands-on demo of our open source tool, data-diff, with DuckDB. So before I move on, I want to give a quick shout out to Doug Beatty of DBT Labs for contributing to the project and adding DuckDB support. The cool part of using DuckDB for this demo is that it's entirely self-contained and you can run it locally without the need to mess around with a cloud data warehouse. And to ensure you don't run into any issues, we recommend that you have the following prereqs. If you don't have all the above here or run into an issue along the way, you can ping us in the Slack channel and we'll try to help. But again, you can always follow along without running this locally. Just for more context, I'm going to be using VS Code in my terminal and just follow the docs in our GitHub repo. And I've got it set up so you can copy and paste and follow along. And there should be a link to the demo repository README in the chat. And just a little quick preview. At the top of the repo, we'll have our prereqs, and you can run the commands at the top. And you'll also want to make sure to check out the DuckDB demo branch that we'll be working from. All right, so without further ado, it's demo time. Got my VS Code and our repo pulled up. So navigating to our demo repo, we want to make sure we're on the DuckDB demo branch. And then just scrolling down to the README. This repo is an example DBT project, and it's seeded with source CSVs. So all the data is contained in the repo. We've got a nice DAG of our project so we can see the model relationships. Hopping down to our prerequisites. Again, we'll need dbt, Python, Git. Pretty much, we assume most people are going to have that already. And you'll want to clone the repo and check out the DuckDB demo branch. I've done this ahead of time, so I'm cheating. We can see I'm here. I'm on the DuckDB demo branch. All right, so now we are ready to install. Essentially, we're going to create a clean Python virtual environment, and we're going to install everything we need. And I'm just going to copy and paste these commands in my terminal and sort of try to talk through this. So first off, this first command I throw in here, we're going to create our virtual environment called env. Second command, we are going to activate the environment. So now we can see we've created a virtual environment and it's on. Next step, we're going to upgrade pip. This is just to be safe. We're going to be using pip to install data-diff in a sec, so we want to make sure we've got our bases covered on that front. Next command, we are going to install our requirements. So this will install DuckDB, the correct version of dbt, and data-diff into our virtual environment. All right. We're going to reactivate the environment to make sure that all those changes were picked up. And last bit of housekeeping, we're going to unset our dbt profiles variable just to make sure our dbt profile doesn't get confused in case you've got that set. So installation is complete. On to setup. So we want to establish the baseline production tables. Notice this is dbt build target prod. Remember, we're creating a DuckDB database from scratch, and there's nothing in there yet. So we'll want to do this build to create our production tables. We'll need those to have baseline tables to compare to. Notice, looking at these models, the schema equals prod. So we're creating all these tables in our prod schema. And then we want to do the same for development. And we're doing this so we have an intact development space with all of our models. Again, peep the schema. We've got dev. So everything is installed. Our dbt project is set up, and we've got tables in both dev and prod schemas. So let's get into properly using data-diff. So I can jump down to my usage. All right, so we're going to mock up a change to a model, then use data-diff. Conveniently, we've got one staged for you, and this is going to look familiar. This is the same code change from the presentation earlier. So if we go models, core, then we look at our dim-orgs model. If we're just going to make a small edit to this first CTE. This is our production. I'm going to comment that out, and our development, we're going to pull that in and make sure to hit save. So we've staged our changes, we've saved it, and now we can run data-diff. Again, we're doing a dbt run, select dim-orgs, and then we're just appending data-diff --dbt. So that just ran, and so we got our familiar looking dbt run, and then it also spat out the data-diff output. Again, we can see what tables are being compared. We can see schema changes. We can see row counts. We can see value changes, all that good stuff that we covered. If we want to run the dim orgs and everything downstream, just like we covered in the presentation, same command, but we just added the plus syntax selector. So that's going to run all 4 models, and then it'll spit out all 4 of our data diffs. So again, we know row count changes, we know schema changes, we can see columns with new values for everything downstream, everything that was impacted. That's really cool. Looking at our DAG for the project, what if I made changes to dim orgs, right? What if I only want to run diffs on this fact yearly financials model? So to do that, we can run a single model with this with our new select syntax. So it's just data-diff and --s select, and then the model name or names. And voila, we got our data diff for our financials table. So we were able to select it ad hoc. Yeah, pretty cool, right? So adding to our demo, sort of a director's cut, wanted to show off some cool new features that were recently released. Yeah, thanks, Leo. New features that were just released, the ability to filter tables and the ability to include or exclude columns. So we do this just by editing our YAML and adding some metadata. So we can add this filter to metadata that will act like a SQL where clause. Example use cases, you could use this to only diff a certain segment of accounts or to only look at recent data. So for this example, we're adding a filter where source timestamp is in the last 7 days. I've got that staged in our YAML here. So familiar looking YAML, looking at dim orgs, and this is our example meta filter. I'm going to pull that in, click save, and run it again. So this is kind of arbitrary. I just picked orgs that were created in May or later. And notice that our row counts changed. So essentially, we're only diffing a subset of records, which is what we expected. And this is really handy if you're diffing bigger. If you're differing larger data sets and we want to just reduce the size of the diff for performance reasons. Showing off the include, exclude syntax. So you can specify which columns to include or exclude in the diff. Maybe you only want to diff primary keys, or maybe there is a column that's is noisy and you don't want to impact that. In this example, that created that column had a bunch of changes, and maybe I'm not really worried about it and I want to exclude it from my diff. So I pulled in this meta changes to exclude the created at column from my diff. So again, if I run it again, notice it's our same dimworks diff that we've been looking at. Oh, whoops. So I didn't save it. That's been a fun part of doing this live. Right. So now that I saved it, we can see that we still have 11 rows dropped, but there are no rows with values changed, and the created at column is not included in that output. Yeah, so thus concludes the demo portion. Let's hop back over. So yeah, once again, how easy was that? With data-diff-dbt tagged onto a normal dbt run, you cover your bases on testing. And I personally use this whenever I'm developing a dbt. Before I open a pull request, like for reals, I use it. Recent example, I ripped out our 5tran dbt Salesforce package. It's a package that automatically makes all the staging models for Salesforce. Under normal circumstances, this would be a real house of cards, pulling out staging Salesforce models, but using data-diff locally, I flipped things over, ran my diffs, and was mostly in the clear. I spotted a few schema changes thanks to the tool, but otherwise it was plug and play. In the before times without data-diff, something like that would be big and scary, but I did it in a single PR and it wasn't a big deal. This new check is easy and it can be consistently applied. So yeah, wowee. Assuming I've convinced you that data is cool, you're no doubt asking yourself, how can I set it up on my DBT project? 3 easy steps: install, configure, and then you run. So you navigate to your DBT project, install data-diff and the appropriate connector. Pretty straightforward. It's a pip install. These are the databases we support. You'll need to configure your DBT project. Data-diff needs help identifying your production tables for comparison. Depending on how your prod environment is set up, you'll need to point data-diff towards your production database or schema. We support those that are using databases as an environment, schemas as an environment, custom schemas, custom databases. Perfect timing, Ravi, with that question about primary keys. The second and last bit of configuration, in order to compare data sets, data-diff needs to know your primary keys so that it can stitch your prod versus dev tables together. So you could tag it in the metadata or with tags to identify a primary key. We realized that having to tag every single one of your models is cumbersome. So we've added primary key inference to a recent release. If the primary key isn't provided explicitly, DataDiff will try to infer a primary key from DBT's uniqueness test. So if you have a single column uniqueness test defined, it will use this column as the primary key. And primary key inference works across multiple columns if you've got a composite primary key. So if you've got uniqueness tests on multiple columns, data-diff is smart enough to infer a primary key. This is an example of us getting great feedback from our community of users and Datafold quickly iterating to improve data-diff. We want to remove friction and make it as easy as possible for folks to use data-diff. Right, so once you've installed and configured your project, to run a data diff, you just run as a single command. You append to your DBT run, or you can run as separate commands. I find myself doing this when I'm developing. I do a few DBT runs as I iterate, and then do a then do a data diff on the latest state. And also, as we saw in the demo, you can use the select flag to specify what models you want to run. So to learn more, and I think I've seen this shared in the chat, but you can follow this link or the QR code. This will take you to our docs and you can get started from there. And yeah, I see Leo's kind of linked there recently. Real quick, I want to thank the Datafold folks who helped out here, particularly Sarah. She's our growth manager who did all the behind the scenes work on this event. Dan and Leo for helping moderate, and to the rest of the Datafold team for doing all the work and let me come up here like a show pony and show off this tool. So any questions, you can find us in the tools-Datafold channel in the DBT Slack. You can also send feedback straight to the data-diff repo, either via a bug report or a feature request. Sincere thanks to everyone for attending and playing along. We're super excited about data-diff, really believe in it, and hope you give it a try. I know we're well under time. Happy to wrap early. Also hang around to answer questions. Yeah, let me. So links up. Yes, tools-Datafold would be the best way to get in touch with us. Yeah, so Charlie asked if data would be applicable for migration projects, such as migrating Oracle tables to Snowflake. So little backstory about data-diff. Data-diff was originally an open source tool for that specific use case of migrating between databases. So the core open source tool can be used for migrations and particularly across databases. Yeah. And Charlie, the expectation there is that when we do those migrations, that data tool is very performant, but it's performant in that it expects both data sets to match each other for there not to be very many differences. So it's that migration use case of I want table A to look like table B, whereas with this integration, we expect to see differences. So just calling that out because it really affects performance. All right. So yeah, any further questions? Hit us up in the DBT Slack and tools-datafold. Otherwise, thanks so much for attending. And yeah, we'll catch you at the next one of these.